Welcome to another video from SkyRadar. After a short general overview of the SkySim, we want to show you today how you can simulate one or multiple targets. So let's first start the radar. We are going to run our simulation with a pulse radar. So here, as you can see, I can set target. So what I will do first, I will create a target which start at position 6 meters at an azimuth angle of 30 degrees and at a position, let's say 7 meters at an azimuth angle of 240 degrees. The target moves with a velocity of 0.1. It can have a radar cross-section of 5, and let's pick the elevation angle of 30. Here we can pick whether we have an SCC on or off, and we can define the transmitter gain. We will keep, in this case, the coordinate system as spherical and the radar elevation angle as 30. The jamming is deactivated, so in this case jamming power is irrelevant. So now let's go to the student panel. In order to visualize the target, we have to start first with a signal receiver as usual. And then we connect the signal receiver to the raw data. And then we are going to take a PPI and an A-scope to visualize the simulated target. We can set the signal receiver to SkySim, as you can see here. And let's connect also the PPI. What you are seeing in the screen is just noise, Gaussian noise, generated by the simulator. So now we can go and press Set Target, and then the target should appear on the screen. So as you can see now, we set our starting position at 6 meters at 30 degrees, and now we can see how the radar will move towards our end position, in this case 7 meters at an angle of 240 degrees. After each scan, the radar will scan the new position of the target. And as you can see here, the target is moving. The target will appear in the PPI scope as well as in the A scope shortly, once the radar sees the target in its field of view. So this is one way how to generate targets for a single target. However, we can generate in the PPI scope and the A scope as many targets of interest as we want. So let's go back again to the admin panel and define this time multiple targets with different properties. So we can add here another target, let's say starting at a position of 5 at an azimuth angle of 60, and add at a position of 8, let's say an azimuth angle of 170, and with a velocity of 0.2, radar cross-section of 10, and let's keep the elevation angle 30. I can add here a third target, say start at position 8, at an angle, let's pick 70 degrees, and at the position 8 again with an angle, let's say 270 degrees, velocity 0.3 in this case, radar cross-section 15, and elevation angle 30. In the later videos, we will show how you can investigate the radar cross-section differences between the radars and how this plays a role in the target detection. So I'm going to set the radar, and we are going to see the 3 targets in the PPI scope. So here the first one, and here are the second one, the second and the third one. Now as we picked different speeds for the radars, they are going to move with different velocities towards their end position. And we can see that our third target is a bit faster compared to the other ones. Once the targets have achieved their end position, the radar will be not able anymore to see them in their field of view. So as you can see, the first target is moving very slow, while the last target is moving very fast. And this will be the potentially last position where the radar will see this target. Exactly. So this is a very simple visualization of the simulated targets. In a later video, we will show you how to work with more complex algorithms like MTI, MTD, MTDDF, and MTI post-processing in order to be able to visualize moving targets so that you can clear out the noise and the standing targets from your radar for different use cases. So stay tuned.